Jai Hind everyone. Today I am going to discuss a new topic from machine learning, that is decision trees. So decision trees is again one different approach, or you can say algorithm, for machine learning. So as the name suggests, it is containing two terms, one is decision and another is tree. So what machine does whenever it trains a model, there are certain situations where we have to decide something between yes or no, or some different values, or we have to take decision. So all those decisions are being taken on the basis of a tree designing. So in this particular approach, we are going to design a tree which will help us to decide among various options available within the world. So what are decision trees? As per the definition, a decision tree is a tree in which each branch node represents a choice between a number of alternatives and each leaf node represents a decision. So as you have studied in data structure also, we design a tree. There are some nodes, some edges which are connecting these nodes. So all these nodes are nothing but these are the decisions. These node represents decisions. These are the leaf nodes, and these leaf nodes represent the decision. And these edges or branches will define the number of choices available. So for this particular example, if I am saying from state 1, or I can say from Delhi, I can directly commute to Bangalore or directly commute to Chennai. Okay, so from Delhi I can commute directly to Bangalore, or I can directly commute to Chennai. Means from Delhi I have only two options: either I can commute to Bangalore or I can commute to Chennai. So it is basically a type of supervised learning algorithms. Means whatever data we are having, we have certain number of options available with us, and all the options are being defined to us. Let us consider one another example. For example, if there is a BTech student, a student who is having BTech degree, right? So what he can does, a graduate student, he can go for further studies, okay, or he can go for job. He has two options only. Either he can go for further studies. If he has done BTech, he can go for MTech or MBA or any other post graduation course, or second option he can have is the job. Now how he is going to decide what to opt? If he do not have any interest in doing job right now, he is not prepared at all, he has completely focused on his study, he will go for the study. But if he choose job, if he has placement option, if he has a good job in his hand, what he can decide? He can decide based upon the location or package. Again, job, I am determined to do the job, but again there are some constraints which bother us. So such like salary package or the location. If location is quite interior, then also we can quit the job or say yes, now we go for the studies, and in future we can again come with some other job. So there are certain situations or the parameters which are responsible for creating multiple options. So all those options are being represented by the edges, and the decisions are represented by the nodes. Take another example. In a body temperature, we have two things, either warm blood or cold blood. So based upon the body temperature, we can categorize warm blooded or cold blooded. If cold blooded are there, it means these are non-mammals. So decision is there कि a thing or a body which has cold blood is a non-mammal, but a body is a warm blood, then again two conditions comes, it can give birth, right? But yes or no. If it can give birth, it has 4 legs or it is non-mammal. Again, if it is 4-legged, it is a mammal or it is a non-mammal. So, all these edges are what? Are the options available, and all these leaf nodes are what? Decisions. So, in this way decision tree works. Now, appropriate problems for decision trees are instances are represented by attribute value pair. Second is the target function has discrete output values. Means whenever we are dealing with the discrete numbers only, then only we can opt for the decision tree. Because we can have answer either yes or no. The training data may contain errors and the training data may have missing attribute values also. So these are the certain problems which are present while we are dealing with the decision trees. Now, how to select the deciding node, or what is which is the best classifier? So whenever we are going to decide, we are going to create a tree, for the first thing comes, we have to decide the root node. So how to decide a root node? So as you can see in this diagram, A, B and C. A is having certain number of blue dots and certain number of yellow dots, almost equal number of A and yellow and blue dots. In circle B, yellow dots are very less as compared to blue dots, and in part C, all dots are blue. So which node can be described easily, A, B or C? So the answer is less impure node requires less information to describe and more impure nodes require more information. What is the term impure here means? Means the data which is not segregated. As decision tree comes under the supervised learning, so each and every node must be clarified, classified, known to the machine. And if there is some impure data or the node or data which is not clear to the machine, that is impurity. So if the number of impure nodes are more information is required, and number of impure nodes are less information is required. So based upon this, we will decide the root node of the decision tree. So information theory is a measure to define this degree of disorganization in a system, which is known as entropy. So with the help of entropy, we will decide the root node, or you can say decision making nodes of the decision tree. Now, how to calculate this entropy? This entropy is calculated using this particular formula, that is summation of I1 to C minus Pi into log 2 Pi. So entropy is a measure of the uncertainty about a source of messages, means we are calculating about the impurity. So here the P is the proportion of S belonging to class I. What is P here? P is the proportion of S. S is the total set of data. So P is certain set of data which is being impure or present within the data set, and we are calculating the value. So this is the formula which is used for calculating the entropy. Now if entropy is 0, all the members of S belong to the same class. Means for example, we have the circle C in the previous diagram, A, B and C. C was having all the blue dots. So entropy is 0 if all the members of S belong to the same class, all the dots are blue. Now entropy is 1 when the collection contains an equal number of positive and negative examples. Means circle A, yellow and blue dots are almost similar, and if entropy is in between 0 and 1, that is, the collection contains unequal number of positive and negative examples. Okay. Now, next term comes the information gain. It decides which attributes goes into a decision tree. To minimize the decision tree depth, the attribute with the most entropy reduction is the best choice. Okay. So, information gain will decide that which node will be kept within the decision tree, and to control the depth of the tree, we select the entropy reduction, the attribute which is having minimum entropy reduction. So, this is the formula for information gain. So, whatever is the entropy which we have calculated with the previous formula, from that entropy we will subtract SV upon S into entropy SV. This is what? This is relative entropy of S. So, original entropy we have calculated previously using the formula. From that original entropy we will reduce the relative entropy of S, and based upon that we will decide which node is going to be exist in the decision tree as a root. Now, what are the various issues in decision tree learning? So, first is how deeply to grow the decision tree, means to decide the depth of the decision tree. Second is the handling of the continuous attributes. It is every time it is not possible to receive discrete values. So, it is quite difficult to handle the continuous attributes or continuous values. Now, next issue which deals with the decision tree is choosing an appropriate attribute selection measure, means how to select an appropriate attribute within the decision tree. And last is the handling training data with missing attributes, means whenever we are not having proper labeled data or some data which is having missing attributes, in that particular case also we find difficulty. Next term comes with the decision tree is the overfitting. So, if a decision tree is fully grown, it may lose some generalization capability. This is known as overfitting. Means whenever we have a complete depth of the decision tree, in that particular case overfitting occurs. So, a hypothesis overfits the training example if some other hypothesis that fits the training example less will actually performs better over the entire distribution of instances. So, that is overfitting. Next is, what are the causes of overfitting? Overfitting can be due to the presence of noise or due to the lack of representative instances. Means data refinement is not proper, then in that particular case we deal with the overfitting problems. That is, whenever we are not properly labeled data or some class is missing or training data is not refined, in that particular case we we deal with the overfitting. So, a good model must not only fit the training data well, but also accurately classify records it has never seen. So, whenever we train a model, a good model is said when the trained data set is also good and the results are also good. So, what are the what can be done for avoiding overfitting for decision tree? That is, approaches that stop growing the tree earlier. Means do not grow your tree very much fastly before it reaches the point where it perfectly classifies the training data. Means there must be always be there a future scope for your decision tree. Approaches that allow the tree to overfit the data and then post prune the data. Next are the Bayesian network. Bayesian network is another approach or machine learning technique which is used to train the model or machine. So, what are Bayesian network? It is a simple graphical notation for conditional independence assertions and hence for compact specification of full joint distribution. in simple way, I can say that the probability of happening something is the Bayesian network. So, what its syntax of the Bayesian network? A set of nodes, one per random variable, a set of directed edges, and a conditional distribution for each node with its parent. This is nothing but the probability, conditional probability table. So, Pxi with respect to parents of xi. So, in the simplest case, conditional distribution represented as conditional probability table, giving the distribution over xi for each combination of parent value. Now, by law, we try to memorize this Bayesian network with the help of an example. So, here I am taking a burglar example. What this example says, that I am at work and my neighbor John calls to say my burglar alarm is ringing. But my neighbor Mary doesn't call. Sometimes it's set off by minor earthquakes. Is there a burglar? So, this is the statement, or you can say problem statement, that I am at work and my neighbor, one of my neighbor calls me that my burglar alarm is ringing. But my another neighbor doesn't call me. And sometimes this burglar alarm rang due to minor earthquakes also. So, in real, is there any burglar present within my house or not? So, what are the various variables which are being used in this problem statement? Are the burglary, earthquake, alarm, John calls and Mary calls. The person who called me is John and who didn't call me is Mary. What rang? Alarm rang. Now, alarm can be rang for two conditions. One is burglary, that is a thief is there, and another is a minor earthquake was there. So, network topology reflects a burglar can set the alarm off, an earthquake can set the alarm off, the alarm can cause Mary to call, and the alarm can cause John to call. So, these are the questions which are to be answered. Now, with the help of this particular data, I can draw this alarm is rang. Okay. Now, this alarm rang either due to burglary or either due to earthquake. And when this alarm rang, either John will call or Mary will call. Okay. Now, what belief network data set is being given, that is, this is the probability. Probability of burglary is 0.001, probability of earthquake is 0.002, probability that John calls is 0.90 and it does not call 0.05. Mary calls it's 0.70 and does not call 0.01. And this is burglary and earthquake. Means an alarm can run for both when burglary is there and when earthquake is there. When burglary is there and no earthquake is there. When no burglary is there but earthquake is there. And when these two are not present. So, based upon this data, we have to calculate the results. So, what we will do, based upon this formula, that is probability John calls or Mary calls or alarm rang and or not burglary and not earthquake. So, keeping all the values in this particular formula, we can calculate the result. So, this condition may vary, that is John call or Mary call or alarm rang or burglary or not earthquake. So, conditions will change but formula will remain same. So, in this way Bayesian belief network will work. So, I hope concept is clear. So, formula will become this. So, for I is equals to 1, We will add one by one all the conditions, and based upon that we will calculate the results. Okay, this is what? John or Mary calls. John called, no. Alarm, again no. So based upon the probabilities, we solved the example. Thank you so much. See you in the next.